All right. Hey guys, once again, welcome to our channel. Hopefully, you guys are doing great. In today's brand new video, we'll be discussing a brand new concept. All right. So, as I promised in my previous video, so just to recall, just to review that, I have already covered the electronic configurations part, where we discussed determining electronic configurations, basics of them, the spin pair repulsion, how the electrons are arranged, writing out the electronic configuration two different ways, splitting of the periodic table, and etc. etc. So make sure you check out those videos before you jump into this video. Anyways, so as you can suggest by today's video's thumbnail, that the concept that we have taken to deal with in today's lecture will be ionization energies. All right. So there's many things to discuss in ionization energies. I think that this will take a time of a period of 3 videos. It's a course of 3 videos. Okay. We'll be discussing ionization energies, successive ionization energies, water ionization energies. So this all will be discussed in these 3 videos. Okay. It might take more than 3 videos. I'm not promising that, but I hope that we just cover this within a period of 3 videos. Okay. So without wasting our precious time, let's get off with ionization energies. Alright. Now the main question that wanders in your head, around your mind, when you hear the word ionization energy. What is ionization energy? So let's not go by the general definition. Alright, let's not go by the general definition. Let's see the idea. Let's imagine when you hear these two terms, ionization and energy, what comes to your mind? So, talking about me, when I hear these two words, ionization and energy, I think that ionization, firstly, that ionization that I'm making an atom an ion basically. Maybe a positive, maybe a negative, depends. Okay, but in ionization energy, we are forming a positive ion. But what is the idea? I'm trying to explain. Alright, so the idea that we're trying to explain is that ionization is basically you are making an atom an ion. Okay, and energy, ionization energy will be in total that's the energy required to make an atom an ion. This is the idea, general idea that I'm trying to give you. Now let's see what CIE, this is the syllabus, the Cambridge curriculum, asks you for the definition. If they ask you what is ionization energy, what you will reply. Okay, so the answer, the definition that we will be giving is that the ionization energy, abbreviation IE, of an element is the amount of energy required to remove 1 mole of electrons from 1 mole of gaseous atoms of an element to form 1 mole of gaseous ions. Okay, so make sure whenever we're writing these definitions, you write these definitions word to secure your mark. Maybe you missed gaseous, gone. Maybe it's a 1 mark question, you lost that 1 mark. And we know how important is every mark in your exams, in your CIE exams. It may be ACE level, it might be IGCSE, it depends. But every mark is important when you are answering these questions. Okay, moving on. Ionization energies, now these are measured under standard conditions. Now these standard conditions are also important that you should be aware of. You should be knowing these standard conditions. Question might ask you, what are the standard conditions for ionization energies? And you should say, there are temperature of 298 kelvins and a pressure of 101 kilopascals. Alright. Now, coming to units, the units of ionization energy are kilojoules per mole, that in kJ to the power mole minus 1. Okay, moving on. Now, there are different ionization energy. Not different, actually, there are infinite ionization energies, I would say. Suppose for hydrogen atom, there is only one ionization energy because there is just one electron. As you go further across the periodic table, maybe the last element, you will see it has 237 electrons, let's say. No. Let's say it's the last element, 118th element. okay, and it is having 118 electrons. So we'll say it has in total 118 ionization energies. So from first to second to third to fourth, and it goes on further to 118th ionization energy. All right. Now, people might ask you, not people actually, the examination question might ask you that what is the first ionization energy? Okay, so you should say that first ionization energy is the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms of an element to form 1 mole of gaseous plus 1 ions. Actually, I forgot to write the gaseous, so apologies for that. Okay, so likewise we'll be answering. Okay, let's talk about the second ionization energy. That's an example, second ionization energy. So your second ionization energy, that will be IE2, is the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms of an element, from 1 mole of, not gaseous atoms actually, it's gaseous ions, gaseous plus 1 ions to form gaseous plus 2 ions. So you will see that in third ionization energy, let's talk about third ionization energy. And what will happen, that in third ionization energy you are forming a 3 plus gaseous ions, and this means you are forming the 3 plus gaseous ions from a 2 plus gaseous ion. That's the all the thing that you need to understand. Okay, for example, let's take the first ionization energy of gaseous calcium. So again, what is it? That you are forming a calcium plus 1 gaseous ion from a calcium gaseous atom. That's here. So basically you are adding an electron. No, so you are removing an electron. Okay. So calcium gaseous will produce calcium plus gaseous, and that's how is it formed, by removing an electron. And the ionization energy for this is plus 590 kilojoules per mole. Why is it so? Why is it positive? Because you're removing electrons, you're forming positive ion, right? So that's why it's positive. You don't need to know anything about the ionization energy. You just need to understand the idea of how we can determine if the question asks for second ionization energy, third ionization energy, the definition, the standard conditions, and the units. Moving on. Trends in ionization energies. So, talking about different elements, you will see that different elements across the periodic table will follow different trends in ionization energies. So, ionization energies show periodicity. What is periodicity? It's a trend across a period of the periodic table. So, those trends that we're going to discuss in this slide. So, as could be expected from their electron configuration, from all the elements electronic configuration, we will see that the group 1 metals have a relatively low ionization energy, whereas the noble gases have very high ionization energies. So you get just my tongue got stuck there. All right. So why is it so? The question is, why group 1 metals have relatively low ionization energies, whereas the noble gases have very high ionization energies? What is the reason behind it? Now the reason behind it is some factors. Okay, the some factors are the 4 factors that will affect your ionization energy. Okay, so the size of the first ionization energy is affected by 4 main factors. The first factor is the size of the nuclear charge. Okay, the nuclear charge is basically the proton number here. Okay, just imagine that you're increasing the number of protons, you're increasing the nuclear charge. A decrementing number of protons will be decreasing nuclear charge. Distance of outer electrons from the nucleus is the second factor. In other words, we can say it's the atomic radius. That's atomic radius is the distance between your nuclei to the outermost electron. Okay. Shielding effect. Now shielding effect of inert electrons. Now let's take, for example, you have a calcium atom. Okay. In calcium atom, 20 electrons are there, and those 20 electrons will occupy different shells. Okay, from inner shells to the outer shell. Okay, now what will happen? The electrons in the inner shell will repel the electrons in the outer shell, and the more and more inner shells are present, what will happen? There will be more electrons, and more electrons will be repelling more the outer electron, and this will increase the shielding effect. This is what that is called shielding. Okay, spin pair repulsion. Now spin pair repulsion is also an important factor. What happens when there are 2 electrons, as we discussed in one of our previous video, in electronic configuration, that spin pair repulsion, electrons with similar spin repel each other, which is also called spin pair repulsion. So that spin pair repulsion can help to decrease the ionization energy. If there is spin pair repulsion, there is a lower ionization energy. Why? Because those electrons are repelling each other, and those electrons can knock out each other because they are repelling each other more and more. That's why spin pair repulsion is an important factor. Now, what is the main trend? Let's come to the main point. First ionization energy increases across a period and decreases down a group. The question might be a bit inclusive theory that why is it so? Okay, they might ask you why the first ionization in energy increases across a period and decreases down a group. There are some reasons that you need to understand. Let's check those reasons first. Now, before we check those reasons, let's see how the ionization energy of elements from hydrogen to sodium. You will see that hydrogen, now this graph is not very important, okay, but similar graphs could come in your question and they might ask you the examples that I'm going to give you in the next slide. They might give you this type of graph and they might say why is the ionization of energy boron less than the beryllium. So there is a pattern, there is a similar pattern that will be followed in your examination questions. So we'll follow, this is just an example to explain you how the questions can come in your examination paper. All right, so let's see to that. Now, ionization energy across a period. We saw that it is decreasing. It is increasing, right? Yeah, increasing across a period. So ionization energy across a period generally increases due to the following factors. Across a period, the nuclear charge increases. Nuclear charge is what? The number of protons. Okay, the number of protons is increasing, the nuclear charge is increasing. Now what will happen? We know that as we go across the period, the number of shells remains the same. Okay, this means that shielding effect is the same. Okay, is constant. What will happen? As this nuclear charge increases, there is a tug of war going on between the nucleus and the electrons. And in this case, the nucleus is winning. Why nucleus is winning? Because as it is gaining electrons, as the atomic number is increasing, as the number of protons is increasing, it is pulling those outer electrons more strongly towards itself. That's the attraction power, we can say. Okay, so its attraction power is increasing across the period. So what happens here? The outer shell is pulled closer to the nucleus, so the distance, the atomic radius in this case, will decrease. The nucleus and the outer electrons decreases. Now talking about shielding, again shielding by inner shell electrons remains reasonably constant as electrons are being added to the same shell. So the number of shells don't change, only the number of electrons are increasing, and the shielding probably remains the reasonably constant. Now what will happen? It becomes harder to remove an electron as you move across a period. Since the atomic radius has decreased, shielding effect is the reasonably constant and nucleus is attracting more strongly. So it's basically difficult to remove that electron. It is basically you need to apply more and more energy to remove that electron. Okay, so the ionization energy will increase. This is the reason. Moving on to dips in the trends. Now we saw some dips in the trends in our graph that I showed you in the previous slide. You will see there is a slight decrease in ionization energy, that is first ionization energy between beryllium and boron. Okay, let's see that. Okay, this was beryllium boron. You can see that beryllium is higher in ionization energy compared to boron. What is the reason behind it? One second. All right. Now, fifth electron, as the fifth electron in boron is in the 2p subshell, which is further away from the nucleus than the 2s subshell of the beryllium. That's why. Now, if you talk about beryllium, it has a first ionization energy of 900 kilojoules per mole. More ionization energy as it like the atomic configuration 1s2, 2s2, 2p, 1s2, 2s2. Boron has the first ionization of energy of 800 kilojoules per mole as its electronic configuration is 1s2, 2s2, 2px1. Now, why is it so? Now you will see boron will have a greater atomic radius. One second, guys. Okay. Boron in this case will have a greater atomic radius, right? Because it has a 2p subshell as well. Does this mean the shielding effect will be more? Okay. Right. Okay. The shielding effect will be more and the atomic radius has increased. This means the nucleus is attracting strongly, but not that strongly compared to beryllium because the atomic radius has decreased. This has weakened the force of attraction. Okay. So this means that boron has a less ionization energy. And beryllium, you have 1s2, 2s2. Okay, so you have basically what is happening here, you have two shells, okay, and the nucleus is attracting the beryllium's outer electrons more strongly compared to boron, since it has just two shells and there is only one s subshell. In boron you had two subshells, that was 2s2 2p, and in beryllium you had just one shell, that two shells, okay. In shell number 2 you have just one s orbital, so that's why we can say that beryllium the nucleus is attracting the electrons more strongly towards itself. All right, so this is the reason why there's a dip in the trend between beryllium and boron. Moving on to the decrease in ionization energy between nitrogen and oxygen. Okay, now if you will see in your paper, no, not in the paper, in the diagram that I have given you here, you will see that nitrogen is at the peak compared to the oxygen. Okay, so nitrogen is more has a greater ionization energy compared to oxygen. What is the reason behind it? Let's see. So there is spin pair repulsion in the 2px orbital of oxygen. Now spin pair repulsion, let's see. This is the reason that why there is a slight decrease in IU1 between nitrogen and oxygen. Now nitrogen has a first ionization energy of 1400 kilojoules per mole. We know this from the graph. What is the reason? As its electronic configuration is 1s2, 2s2, 2px1, 2py1, 2pz1. It has a greater ionization energy because there is no spin pair repulsion in the nitrogen. Okay, in oxygen you will see that it has a first ionization energy of 1310 kilojoules per mole, as its electronic configuration is 1s2, 2s2, 2px2, 2py1, 2pz1. So in 2px orbital you have two electrons. So those two electrons are repelling each other, and the repulsion between those two electrons makes it easier for one of those electrons to be knocked out. And what will happen? You will have a lower ionization energy. So if there is spin pair repulsion, lower ionization energy. So in oxygen there are two electrons in the 2px orbital, so the repulsion between those two electrons makes it slightly easier for one of the electrons to be removed. Got it. Next thing. From one period to the next. Okay. Now there's a large decrease in IE between the last element in one period and the first element in the next period. This is because as you're going from the last element in one period to the successive period, okay, and its first element, that is the next period, okay, you will see there's a like drastic change in features, in characteristics. What is happening? This is because there is increased distance, because you are moving down the group here, okay, you are adding a shell, that's why there is increased distance, increased atomic radius. There's also increased shielding, because we know as we are adding more shells of electrons, there will be more repulsion between the inner electrons and the outer electrons, and thus there will be more shielding. And these two factors will outweigh the increased nuclear charge. Nuclear charge is increasing, but that does not affect the ionization energy. These two factors just have a greater impact on the ionization energy. That's why there's a large decrease in IE between last element in one period and the first element in the successive period. Moving on. Down the group. What happens down the group? So the ionization energy, we know that down a group it decreases. What are the factors? What are the reasons? The number of protons in the atom is increased, so the nuclear charge increases. Now this reason, you might think firstly that nuclear charge is increasing, so it means that it should attract strongly together. The nucleus should attract the electrons, the outer electrons, strongly towards itself. This would be the thinking, this would be the logic that you would be providing. But there are some other features as well. There are some other characteristics as well, other factors as well that you have to consider in this question. Okay, what will happen? The atomic radius of the atoms is increasing. Why is it so? Because you are going down the group, you are adding more shells of electrons, making the atoms bigger. This means the distance between the nucleus and the outer electrons increases as you descend the group. Atomic radius is increasing. The shielding by inertial electrons, in previous case it was constant, but in this case it is increasing because they are adding more shells of electrons, and there will be more inner shells that will be repelling the outer shell electrons. Okay, and these factors will outweigh the increased nuclear charge, meaning it becomes easier to remove the outer electron as you descend the group, so the ionization energy decreases. Now this is all you need to know about the trends. Okay, now let's go further. Now here is a summarized table. So if you are facing difficulty in understanding those lengthy concepts, so you can just refer to this table as well. But I would recommend you I would recommend you to go through those lengthy steps, because those lengthy steps will help you get that trends in your mind, get everything in your mind basically. So by this slide, we are done with the first video of ionization energy. In the second video, we'll be discussing maybe the successive ionization energies probably. Okay, so that's it for today's video. Make sure you are subscribed to the channel, hit the like button, comment down below, so as per your suggestion we can improvise that video's content, and also mention any topics that you're gonna face in difficulty. Also, we're going in order, but maybe we cover that first. Don't know where the destiny takes or what I'm speaking. All right, ignore that. Now that's it. Okay, comment down below, hit the like button, and subscribe to our channel, and press the bell icon so you receive our notifications without any delay. That's it for today's video. Cheers.